In this video, we will be going over the decomposition of baking soda lab. Baking soda, also known as NaHCO3 or sodium bicarbonate, can undergo 3 different decomposition reactions. In this lab, we will determine which one is the correct reaction by comparing the theoretical yields of the 3 solid products with the actual yield from the lab. The first step in this lab is to dry our crucible for about 30 seconds. We want to ensure that there is no moisture in our crucible. Once the crucible has cooled down for about a minute, we will weigh and obtain the mass of the crucible, which is 14.14 grams. Next, we will weigh the mass of our baking soda or sodium bicarbonate. We need approximately 2 to 3 grams. And in this case, we have measured out 2.42 grams. Next, we will carefully transfer all of the sodium bicarbonate into the crucible. We will heat up the crucible with the baking soda for approximately 10 minutes until the decomposition reaction goes to completion. Once the crucible has cooled for 5 minutes, we will take the mass of the crucible and its contents, which gives us a mass of 15.66 grams. Here is the data from our lab. Now we will take a look at our data. We started off with 2.41 grams of our sodium bicarbonate or baking soda. We finished with our final product with a mass of 1.52 grams. Now what we want to do is we want to match this 1.52 grams with one of the 3 possible solid products from reactions A, B, and C, which is either going to be sodium hydroxide, sodium oxide, or sodium carbonate. So what we need to do is figure out the theoretical yields for all 3 of these solid products, and whatever the theoretical yield is closest to our final product, that's what we will know we have the correct equation. So what we will do is let's take equation A, for example. That's where we have sodium bicarbonate decomposing into sodium hydroxide and CO2. For the sake of simplicity, I'm going to omit the state symbols. And the first step is we're going to balance this. Now, this equation here is already balanced, so no extra work is needed. So now what we are going to do is we're going to take our 2.41 grams of sodium bicarbonate and figure out the mass of our solid product of sodium hydroxide. So let's do an example calculation here. Let's start with 2.41 grams of sodium bicarbonate, and then we will convert this into moles. Oops. And the molar mass of sodium bicarbonate is approximately 84 grams. Next, we will convert this into moles of our sodium hydroxide. Since this is a 1-to-1 ratio, we just will put 1 on the numerator and the denominator. And then finally, we will convert this into our mass of sodium hydroxide. So let's take the molar mass of sodium hydroxide. Our molar mass of sodium hydroxide is approximately 40 grams. Now double check here that all your units cancel out. And then use your calculator to determine your final answer, which gives you 1.15 grams of NaOH. Now, what we will do is we're going to repeat this process to figure out the mass, the theoretical yield, the theoretical mass of our sodium oxide and our sodium carbonate. And then we will compare all of the theoretical yields of these three solids with the yield of our final product, and whichever value is the closest should correspond with the correct equation.